Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter. Lately we've been working on infix operators, and we have an approach that works at the token level, but we need to integrate it with our parser that works at the expression level. And the bottom line of that is we need to update our grammar. So let's go over to the IDE. Okay, so the deal is basically right now we have an expression can go to one or more expressions, like a function called function of xy. It just seems to be a series of expressions. We want to extend it so that we can handle that, followed by an operator. Oops. Followed by an operator and one or more expressions, and then that can be repeated any number of times. So 3 plus 4 plus 5 would be handled by this. So would function of 3, 4 plus function of 3, 5. And there's a little complication in that. All right, let's go to the grammar. And I'm going to back us up to parse. Let's see. So basically, right now, our main parser looks and says, if you can start an expression, so like a name or a number or things like that, then maybe you're a function call. Well, we expect you to be a function call or a definition. In Elm, you just say function xy equals some formula. You don't say like let function xy or def or any of that kind of stuff. It's just you're there, and the consequence of that is you get a function call or definition. You have a bunch of expressions, then you have an equal sign, and then some more expressions. And you can't tell that it's a definition until you get all the way to the end of the first expressions and see an equal sign. But that first expressions, it could be function calls, it could have parenthesized expressions, it could be any arbitrary list of expressions, and they can be arbitrarily long. So there's no kind of bounded point at which you have an equal sign and it's a definition. So we're doing that in a mix of we have a fairly general statement here. Function call or defs goes to expressions equals expressions, and the last part's optional. If you don't have the equal sign, it must have just been an evaluation. And if you do have it, then you shouldn't evaluate, you should define a new function. And since you can't decide until way late, we can't like assume we're doing evaluation, and we have to kind of defer some things till the end. All right. And when we see the equals, then we know we have the definition and we can do the rest. Right now, we just return the parsed expression as a kind of a wrapper thing. All right. We can ignore function definition for now, although that will change too. But let's see. So down here, expressions. This thing goes to one or more expressions, and at the end of its parsing, basically here it's deciding if it was just a single expression like 7, it just returns it. If it was more than one expression, function of xy, it says, oh, it must be a function call. Now, that's okay for things the way they are now, because more than one expression means it must have been a function call or it's about to be a definition. But we want something in the middle that allows that operator plus. So I'm assuming we're going to put a new rule in the middle here that allows for those operators. So let's write a test. Okay, all the tests are green. Good starting point. Okay, so what we're trying to do, well, this will have some interesting aspects, I guess. Let's test an expression with operators. Okay. So check successful parse. The input, let's do 3 plus 4 plus 5. Yeah, how about times 5? A little tiny bit of complexity. Now, I don't know. I think the way we are today, what does that mean? Well, that's going to be a little challenge. Okay, this one we know is just a function call, and that's fine. But this one, it's got to be... I hate to introduce a new node at this point for things that we don't need it for. Well, if we had our the little parser we've been working on, this precedence operator precedence parser plugged in, what we would get back would be a tree that's like the plus tree with a 3 on the left and a product tree on the right with 4 and 5 as its arguments. And that would be fine, but that feels like a big step. Maybe we can overload this function call. I think for now. Yeah, let's do something like this. So this one just returns the things in sequence. Variable plus 3, 4. I think we can do the same. This is very temporary, and I may regret it. You may regret it even more. Okay, so we got an integer value 3. And then I'm going to say variable plus, this is really arbitrary, integer value 4, variable times, and integer value 5. So what I'm proposing then is basically we want to turn this 3 plus 4 times 5 into some sort of sequence of stuff. And the function call is handy because it has a sequence of stuff, I guess. A sequence of expressions. And we would like to take that sequence of expressions, run it through our precedence parser, and get back a single expression that represents the tree of 3 plus 4 times 5. But for now, just as sort of, I don't want to call it a spike exactly, but sort of an alternative way to go about it. Let's do this. Okay. Now this is clearly going to fail. It's, I don't know, I want to put something in there for a marker or something just to kind of like say, this is really questionable. Okay, hey, surprise. All right, function call 345 is not equal to 3. Okay, because our parser doesn't know anything about plus yet, or very little. So this will get us through the grammar part, and then we can work on the rest. So if we take this, and I think I'll just call it operator expression maybe. Goes to that. And then operator expression yields an expression. All right. Now, the rule for this, it's very similar. Let's results not the right name. Let's call them something. What? Expressions? No. I'll say result for now, and we'll get there. Okay. So it's going to be similar. We're going to parse expressions this time. So the the whole thing that could be a 3 or it could be a function call. Okay. And at the end, we're going to wrap it in function call and return it. Okay. And now this, while is operator of a token, we want to do the append. Result.append. And again, we do expressions. Okay, because we're calling this one. He calls the simpler one expression, so that's the way it goes. All right, we don't have an is operator. We need that. And I think that's kind of like this one. Okay. Let's address that. Function is operator token. It's a Boolean. Well, I guess the easy way default is return false, and then we'll just list some of these things. And we had a list somewhere yesterday, but plus and time star, we know are. Okay, and that's good. Now nobody's calling this thing. All right, but let's do that here. Okay, so we'll call operator expression. It will in turn call expressions and keep doing that while, well, we got to consume our token. Let's see. Yeah, get next token. We also need to append it. Let's see. Token. Oh boy. Well, we have an operator expression that's prepared to hold on to a token. I would be okay. I would be okay with whatever it comes up with toString, which I think will be plus. For now. We'll need to wrap it somehow. We had operator expression. Let me see. We had something else, I think. As operator, that's the left and right. We just created that one yesterday, I think. It wouldn't be terrible. I mean, we need something to wrap a token so that we can use it later. But okay, let's do this. All right. So we know the token is something we're going to append, and we said we would just do variable, and it takes a name, which will be, we'll just print the token. Okay, so I think it's going to turn into plus times, stuff like that in our expected. Okay, so we see a token, we consume it, and then we call the expressions to get the next expression, function call or whatever. And these get appended, these get appended. That is good. All right. This one didn't need to do next token because the first, when you have two expressions, fn, x, y, the x, there's the x is the start of the second expression. So we have no tokens between them. All right. That looks good to me. So my hope is this passes except for the token names. And what I think, well, yeah, there we go. What I think we're going to have to do is kind of, we're going to have to do some wrapping of these tokens. All right, now this I didn't expect to fail. Oh, right. If there's only one thing in there, we should just pass it back. Okay, now how about this one? Function call 3, variable plus, variable star. Okay, I can live with that part. That's the problem I expected. Okay, now this should make this test pass, but 219 there will still fail. I got a lot of red bars, red stuff there. Okay. 219 and all its brothers and sisters. Function call. Okay. Yeah. We will do the same thing we did down here. If the count is 1, we'll just return it. Result.count is 1, return result sub 0, else wrap it in a function call. Okay. And this will change slightly as we integrate our new parser. Okay, but it does work. Okay, that's good. That was easier than I expected. That has to happen that way once in a while, right? Okay, now we don't have our full list of operators. Let's get that. Where did we... Let's see. We had this. Did we have a test with all those? Yeah, there's still something going on there that's not quite right. Okay, where was that list of operators we had? We had all of them. There it is. Okay. Now, it's kind of hard to know, like, what's the right place to keep track of the fact that these operators are operators. We have arithmetic ones. Well, let's change this around. Let's make operators equal is a set of token equal to this. And if you're set, we could answer return operators dot contains token. Okay, this should be a refactoring as far as we're concerned. We are adding this. Yeah. Okay, should still pass. Yeah, I just don't know. Well, this is the list, isn't it? This is a bit of duplication. That's what bugs me. I wish it didn't move you when you did that. Okay. All right, I think we'll live with it. At some point, we may want to come in and put characteristics on these things. Well, maybe we should anyway. Maybe. Okay, let's check this in. Check for operators. All operators. I don't know. Did I skipped a check-in, I think. All right. I look at this, and it's a token and asking about tokens and token. It doesn't really belong on the parser. It belongs on the token. So let's move this method. I guess Lexer has our token class. Okay, so enum token. I think we can just say extension token and put this. Is an operator. Well, let's start it this way. Static function is operator. We'll just move it slowly. So I think now I should be able to say token dot is operator of token. And that implicitly returns. See if we've done a successful move. Good. All right. So that takes care of that. Now, token is operator. Why should we pass in a token when we can just answer it for ourselves? So let's try that. So token we don't need, and this should do it. Is operator, and it asks about itself. Okay, and then we'll call it here. Token dot is operator, and run. Cool. Now we can inline this. I'll just move it up first. Where's our operator expression? Put it right up here for now. Okay, is operator of token. We should be able to say token dot is operator. Now nobody's calling this. We'll just dump it. Okay, so while the token is an operator, and the structure is very similar. While you can start the expression, while the token is an operator. So that's kind of useful. The operatorness seems more inherent to being a token to me. The starting expression, that sort of depends on the grammar, and that's more the domain of the parser. So that's part of, I guess that's why I see a difference there. But I think we're okay. I mean, this is not. Well, let's find that. Can start expression. Yeah, I mean that's all token stuff too. The tokens clearly are defined. I mean, they're related to the grammar, but well, let's commit what we got. So we moved is operator to token. That's a refactoring. I guess in principle it's not really any different. So let's do the same thing. I mean, I can argue it, but like the fact that the operators are operators, that's also a parsing decision in some level. So having the token know some grammar things, yeah, well, I don't know. It seems okay to me, and it is the case. Everything in here is token, 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 token. You know, there's nothing about parsing in here. So we'll take this. We will move it over to Lexer, and this time I'm gonna be a little more take a little bigger step. Okay, so I know we don't need to pass it, and switch token should be switch self. All right, and then back in the parser, we should be able to drop this. Where's our while can start? There we go. So this becomes token dot can start expression. That okay, that should be a refactoring. Who's got a problem? Did we have that twice? Can start expression token and expressions. Oh, and the parse too. Okay, yeah. Was 120. 104. Okay. What did I see at 120 now? Nothing. Okay. Try again. So if we were doing TCR, that would have reverted because any failed refactoring would have reverted the code. Okay. We moved can start expression to token. And I think we'll do the same approach. Let's just let starters equal, and then let's put all these things. It's a set of token. Okay. What's your problem? Okay. Set of token, and it's token.int. Why is that ambiguous? I don't think it is. Return starters dot contains self, and then this should go away. I'll comment it briefly. We got the same thing there. Why? Let's just do a build, see if that goes away. Why is that ambiguous? Let starters of set of token equal. Really? Is it just this dots? I don't see any difference other than that. And oh, that's why we did that. Because these things are standalone, so there's no issue. But these can have attached information. All right. Was not totally arbitrary. Where did we go? Lexer. Okay, so I don't need starters anymore. Switch self. I think this still should work. and the diff is empty. Okay. All right. What else? Right? When there's one, there's often many. Now this is translating, right? So, okay, handle operators we don't need to worry about. Token int, skip over the token, but return an integer value. So it's basically converting the int to a tree. I mean, the token int to a tree integer. That's a good thing. And the rest is parsing. Okay. Let's see. So I think we're at a good place there. All right, now we're I think we're probably at the moment we got to confront our double parsers and deal with it. Well, So one thing is we don't want variables. We really do need some sort of we need something to contain these tokens. So what we're doing, this is a consequence of kind of shifting, kind of managing the two parsers. We're going to try and pass some stuff through, like the token, like the plus and the times, those operators. We want to treat them as tokens in our new parser. But they're temporary. They're going to be created only for the purpose of letting the new parser convert it into a true tree. Okay. So what I'm thinking is almost like a token expression or a token holder or token container. And it's really a temporary thing. Intermediate token. I don't know. I go through the thesaurus a lot for these names. Maybe too much. Token expression. Token container. Or holder. We have operator. Let's look at that, but I don't think it's going to be suitable because it really wants left and right hand expressions. Now, we could use this. I mean, we could force it. Right, we could call empty expression, which just is a placeholder. Maybe that's the thing to do. We'll make an operator. We'll throw placeholder empty expressions in. The new parser is not going to look at those left-hand side, right-hand side. It's just going to look at the operator and say, "Oh, it's an operator token. Let's drop it in." Okay. So we could do that now instead of these variables. That would be a step forward. Let's do operator. And this is token dot plus. And the left-hand side is empty expression. I think we can do that twice. Let's let... Okay, so let's use it here. Empty, empty. And maybe this we can... I want to make it a sequence, vertical formatted. operator empty integer value operator dot star token dot star. Okay. So now we're saying in our hypothetical, well, not hypothetical, in this new world with operators coming in, we're going to create operator trees, but they're going to be empty. And then our new parser will fill them in with the links to 3, 4, and 5, taking into account the precedence and all the stuff it does. Okay. That seems another step forward. Okay. So I do this often enough. I'm trying, the first phase was just trying to get the shape of the thing right. And now I'm going to try and get these particular values the way I want them. And I think that'll be, I think it's a good move. It's kind of, I don't know, I wrote a few weeks ago, maybe a couple of months ago now about, you know, you can do these things that are kind of intermediate between a spike where you plan to throw it away and a full-fledged development. You know, if I set myself these intermediate milestones, as long as I keep track of them, it's okay. And we're keeping track at this point. You know, it's just this one thing. So if the token is operator, we're going to append operator with the token. And an empty expression and another empty expression. Have I got too many parens there? It looks a little heavy. Oh, that's the operator. Okay. I think this is good. I think that'll pass. All right. So we make of an operator expression return a tree list containing operator nodes with empty expressions. Cool. Okay. So I think the next step, well, let's get our to-do. This is the 7th April, and I still can't type the date. All right, infix operators. We have done this. And now we are implement the operator precedence parser to work on our new list of expressions. Oh, yeah. That's true. Excuse me. So right now our parser looks for tokens, but we're feeding in sequences of expressions, and that tells me we're gonna have to modify our parser, which, well, we knew this day was coming. Okay, everything is input token. We're going to change it to work with expressions. And you're going to give it the list of expressions, just like we are now producing. And you're going to return, well, a list of expressions. Actually, I think you're going to return one expression. So it's not a horrible change. We have to look at how we do relations. Now, the relationships we define are between operators and tokens. Either we, well, we'll have to look at that mapping. Yeah, that's where the work is going to be. We'll change some types here, but we'll have to really deal with it on the other one. All right, we're due for a break, so let's take 2 minutes. We'll come back, get the parser, operator precedence parser working with expressions, and then hopefully we just have to plug it in. See you in 2 minutes or so. Welcome back. All right, so we have our parser, and I think what we need is our input needs to become expression. Our output needs to be expression. I don't know about this end of file. I guess expressions will be on our stack. The thing I think we can do, well, we're going to have to figure out what to do about EOF. That's a little tricky. But I think when we get the relationship between the stack token and the input token, we can actually map that. We can map our expressions to tokens. So let me show you what I mean there. So right now we have this precedence table builder, and we had all these rules, like these things. All right, they say this one, the identifier greater than dollar means, if you compare the an identifier to the end of the stream, you say the relationship is greater. Okay. And we didn't really break out like, oh, it's identifier, but it's lowercase name. Well, we noticed lowercase name. We said, oh, you got to be an uppercase name, but we also have integers and floats and, any other kind of operand, function calls, and all that stuff. And so I think what we're going to do, I think we can just map our expressions to tokens. And then the precedence table stuff pretty much stays the same. Now, we may even be able to simplify it because I want to treat identifiers upper or lower and numbers and floats and really like anything. I mean, unless it's an actual operator or a parenthesis or a something, we don't really care. All right. So in that sense, yeah, I think we can work around it like that. When we do the comparison, we'll map the expression to a corresponding token. If it's an operator, it maps to the token the operator contains. If it's anything else, it maps to lowercase name, say. And the end of file thing, I think that sort of says our input stream should be treated as having an input end of file. We can work on that. Maybe our operator precedence thing should add one. Yeah. All right. So let's see. How can we do this? Well, one thing is array of token. Okay, so that's the result thing is the expressions. Okay, it yields an array of expression if you give it expressions. I just trying to figure out what the incremental change is here, and I don't know if there is a good one. Yeah, I just don't know. I'd like the input to be expressions. And that's going to break a bunch of tests too. Well, one way would be just duplicate it and then just tackle them one at a time. Can I do that? Yeah, let's do that. What is the initialized precedence table? Okay. All right, so if my input is expression, oh, and I'm tying into, well, that's breaks expression. Okay, my result is going to be expressions. My stack is going to contain expressions. And let's add operator into file empty. Okay. What don't we like? Comma. Parenthesis. Sorry about the noise there. Okay. So I'm just trying to convert line by line stuff. So end of file is this. Hopefully end of file is kind of an accepted abbreviation. Tac token equals, let's say, not that, but that. Okay. Precedence relation. Yeah, that's a little awkward. Relation, that stuff's fine. Stack.last. Last popped. Of type expression. The precedence relation is confused. Okay, but that's kind of okay. Let's do, well, let's make a precedence relation. Yeah, I'll do it this way. We'll say expression to token of stack token and expression to token of input token. Same thing down here. Precedence relation of last popped and stack dot last. Okay, now we need this expression to token method. Func expert to token. It takes an expression, yields a token. Okay. And all right. If, can I say, otherwise, I guess this one's probably the right. Variable binding in a condition. How about, well, what is the other way? If expression is operator return try that. Has no member token. What did we call it? Op. Okay. All right. So that's kind of a mechanical translation, I guess. And now I want to take my tests, precedence parser tests, and let's translate them. Well, I guess we're going to leave behind the old one. So let's just tackle one at a time. Okay, so the precedence parser parsing nothing, which is operator EOF, empty expression, empty expression. Okay, so cannot convert value operator to expected type array of token. Let's rename this to parse2. Let's rename the first one, this one, to parse2. Okay, so now if we do parse2, we're getting the old one, and parse should be getting the new one. So I'll do a build. Okay. Yeah. All right, so we've basically converted the first test to try the new version of parser.parse, where the old tests try parser.parse2. Okay. And then I'm going to pull this out. And I'll make a token. We'll do that up here, so we can use it down here. And you know what? Let's stop for a second. Let's make the operator accept empty expression as a default for those two things, and then we can more easily work with things. Okay, so expression equals that, expression equals that. I'm hoping, I don't think we'll forget them that much, but I think it makes this stuff go a little better. Where's my, here we are. Okay, I like that. It'll catch up. Okay, this is just end of file. This is operator, comma. And we're being a little loose in the semantics that, like, operator comma doesn't really mean anything, but we're gonna pretend it does. We could block it somewhere else, but I think the parser itself is going to block the use of it, so it's not going to show up in a real case. Or, well, if it shows up in a real input, the parser is not going to do it, because it's going to say, this is not a, it's comma cannot start expression. We did the token can start expression. Okay. Now this becomes variable. We lose the dot. Lose the dot. And we expect to get back the same variable. Okay, so parse variable into file. We expect post order to be variable x. Yes. Variable A. Variable B. Variable C. And this is operator dot plus. End of file. We'll have to add that end of file. So let me add that to do. Hopefully that communicates it enough. All right. A plus B plus C, I think. That's okay still. We're working with the precedence level there. But then here, A, B plus, and then variable C, and then operator plus. We're calling parse. Okay, good. Do I have a problem? Cannot find plus. More variables. And these operators. Okay. Okay, one more, I think. Let's get the variables first. Whoops, what am I doing? A, B, C, D, E, F. Expression, okay, and let's get our operators. Well, we have an operator star. Star, star, plain EOF. Oops. This one is A, B, C, D, E, F, star, up, up, star, plus. Okay. And tests like this where we just throw a complicated thing at it and hope it works, and we find out it does. You know, it's sort of implied that it worked from all the little pieces we did, but seeing it all together is reassuring. All right, so I think we have a parser that takes expressions, and we don't need little parse2 anymore. I guess a valid question would be, why can't we use this parser for everything? And the answer is the Elm grammar doesn't meet the requirements that you have for an expression precedence parser. So precedence parsers need a grammar that is really just like term, operator, term, operator, term, and Elm has function XY. Doesn't have the parentheses and the commas like you have in Java or C# or 8 million other languages. It just has the calls directly. So it's not a compatible grammar. You might be able to work around it. We sort of know if you have a string of identifiers, then they sort of qualify. You could kind of treat them as the same, but yeah, it you know, when you don't meet the requirements, it's sort of asking for trouble if you try and use it anyway. You know, there's well-defined grammar support for non-operator grammars. I mean, we're doing it with precedence or recursive descent. All right. So what we've done is we converted the operator precedence parser to take array of expressions and return array of expression. Okay. Now, where's that other thing we had? We had good old post order. Also working on tokens. Input tokens. All right. Let's convert this to. I'm tempted to. Yeah, I'm tempted to just do it. It's not very big. And if I let's see. If I do it directly and it all works, I'd be pretty confident because I think most of this is, yeah, it's just not that hard. But let me go back to this parser for a minute. I think we left tokens as a name. Stack input, yeah, stack token is maybe we could call it stack top. Would that be better? Let's do that. Top of stack. And this is current input. I think the only tokens are export to token. Yeah. Cool. Okay, so make sure that works. So height diversion, okay. Precedence, parser, test, precedence builder. Where'd post order go? And there are post order tests. Okay, so let's just do that expression. This is where you can see the name tokens really gets in the way. Okay, and all right. So if the tokens they're really input. Well, let's at least rename this one. Okay. We're not switching. This is really expression. I don't think we can. Okay. Expression. Okay, now this switch, I think all we care about is it an operator or not? If it's not an operator, we're just going to push whatever it is. Okay, so I guess I'm kind of duplicating this. Let's just, if expression is operator, we're going to do something. Well, yeah, we're going to do the operator stuff. If it's an operator, we do a bunch of stuff. We're not going to think too much about it. We're just going to kind of block it in there. Else, it's not an operator, and we're going to do something else. We're going to do this. Okay, we'll come back to it. All right, so all operators, we do a bunch of stuff, and then at the end, we return that. So I think these things can comment for now. And we're missing a brace. Okay, if the expression list is empty, we have an error message. Okay, if the expression is an operator, well, let's handle this case. If the expression is not an operator, we're just gonna push it on the stack. If it is an operator, we're gonna get the right-hand side. We're gonna drop it left hand, and now we're gonna make an operator of expression.op left and right. Okay, so basically, well, I have to. We know it's an operator. Let's do that. Okay, so if we have an operator, we pop the last thing off the stack as the right hand side. The next to the last thing is the left hand side. This is the input. So this is A B star. We hit a star, which is operator star empty empty, and now we're going to push an operator with the actual left and right hand sides. So I think that's okay, and that can go. It's simpler in some ways. There's less that can go wrong in a sense. Okay, and then the tests, we're just going to convert them kind of mindlessly. Did I get the types right on there? Post order expressions, yeah. Okay, so empty list yields an error. That seems like it's not going to change. Well, let's just run these. Oh, it won't compile. Okay, so this is a variable x and should be variable x. It's not awake yet, I think. Yeah. Okay. Our input is of type expression, variable x, variable y, and $0. Let's just do operator of $0. Operators $0 is the token, but we're going to wrap it. So we're saying xy plus, xy times, xy minus, all those things. All right, and then the post order, we should get a variable x, variable y with the operator. Yeah, that seems right. Same test, basically. Do I really need this? Is that ambiguous? No. Good. Okay, operator x, variable y. Same thing here. Okay, I expect these to pass. All right. I don't know if I can call this a refactoring, really. We switched the types around. Changed post order to work with expression instead of token. I ran all tests, yes. Okay. All right. This is a good place to be. Okay, so implement operator precedence parser. Let's say and post order to work on expression. We've done that. Well, modify. All right, I think we're getting there. All right, this is modify operator expression to add end of file token to end of array because the new parser needs it. Okay, but that should be pretty simple. Let's get parser. Okay, so we've got to find our operator expression. And yeah, if the count is 1, we just return it. If it's not, we need to do the append. So let's get a test. I'm sure. Yeah, we want to see a token in the file here. Operator end of file. All right, and notice we got rid of that empty stuff. We defaulted it. That makes this test a little simpler. Okay. Prefix operator parses as a function call. That's correct. Okay, I think this is the only one that cares. And should fail. Okay, it should be missing the EOF. Operator 5 star 5 EOF doesn't match. Yep. Okay. Let's slide that over. Okay, so I'm going to change the return a little bit. If result.count is 1, return result sub 0. Otherwise, result.append operator.eof, and then return, for now, function caller result. Okay. That should pass. Cool. Make operator expression append end of file to true. I don't know. To its output array. Okay. Now, our parser well, we did that. All right, now we're to the point we want the new parser to work with the original parser. Oh, the thing we haven't done, add semantics of operators. So even if we get this thing returning a proper expression with the operator tree and all that stuff, our evaluation doesn't know what to do with it. And we can hard code a little, but I think we want to integrate more into our primitive stuff that we did a little while back, a couple weeks ago. All right, so merge the new parser with the original parser. Okay, so I think again we're going to be modifying this. So we don't want a function call. 3 plus 4 times 5 should be well, the precedence is 4 times 5 first, so we have to put the plus on the outside of that. So the operator is plus. And oh, I wish this thing would. I want a specific nesting, so I'm going to be. All right, so the left-hand side is the integer value 3. And the right-hand side is going to be an operator. Okay, that one goes there. This one is dot times, oops, star. And then we need integer value 4 and 5. 4, 5, we don't need that. Right, okay, so a parse of 3 plus 4 times 5 should be an operator plus with an integer on the left, and then the right-hand side of the tree is an operator star with an integer 4, 5. Close that one, close that one. Let's close successful parse, and this thing should go away. Okay. 1, 2. Well, I guess that lines up, and let's do that. You start doing this tree stuff, you're practically writing Lisp, you know? A lot of parens. Lots of irritating, stupid parentheses, as they say. All right, this should fail. Okay, so we expected a nested tree structure, which we don't really show very well, but and we got a function call with the old stuff sequenced as we did before. So we need to insert our parser here and return the post order of our parser. Okay, so this is the big switch over, and I guess we'll take a break first. So I think, yeah, we'll come back. We'll inject the new parser because this result.append stuff by line 100 result is it's an array of expressions, which is exactly the input that our parser wants, and it's exactly that has exactly the output that our post order thing wants. And so if we call post order of parse, we should get the right stuff. Simple. All right, let's come back and see if it is. 2 minutes. Hey, welcome back. Okay, so we are at a critical change. We've got this result as a list of expressions. We want to call our precedence parser. Let's see. So a precedence parser gets created with a precedence table, and you can call parse on it, and it just sort of remembers what you're doing. So let's add a precedence parser to the initialization here. And I think we'll even call it that. Var precedence parser is a precedence parser. Okay. And I think we'll need a table, precedence table. And I think we could just build that thing, precedence table. And it takes an array of stuff, right? Let's go back to precedence parser, precedence table. Right, init. And we have to add, right? Precedence table builder. Okay, we give that thing the list of stuff. Okay. Precedence parser. Okay, and parser. So let's just say of type precedence table for now. Okay, now we need a precedence table. Precedence table equals precedence table builder of triples, token int associativity. Okay, let's we had some in our example. Precedence parser. Where are those tests? Well, parser tests. I think we had to give it the 3, right? Plus star. Complicated one. So yeah, let's do this. We won't put them all in for the moment, just enough to get our stuff to pass. Okay, so we have a precedence table. Now we need a precedence parser. Precedence parser equals precedence parser of and precedence table. Okay, and it's handy to have one around because it doesn't have memory of the expressions. Oh, catch you later, Code Wrangler. It doesn't have memory of the expressions that we're working with, so we can just reuse this thing and we don't have to reinitialize it with our table every time and all that stuff. Okay, so now we have a precedence parser. Operator expression. So instead of a function call of result, let's take the precedence parser dot parse of result, which is an array of expressions. It throws. Let's do this. We need to assign it. Let's see. That's going to be well, where's our post order? Post order tests we call post order of input dot tree. Okay. Input dot tree. Was it? It's do catch. I can't remember. And if we fail, we're going to do what we always do, and we're just going to bail out. Precedence parser result. We had something similar that returned error expression. I'm not sure what the result is. That's unfortunate. Okay. It's a bit more complicated, isn't it? Let's pull this in just to kind of keep it together. All right, so if it's not a single result, then we're going to append the operator EOF so we can parse this thing. We maybe could push that somewhere else, but anyway. We parse according to our new parser. It gives us a post order list of stuff. We convert that back to a tree and return the tree. Otherwise, if that fails for some reason, which I don't think it will, but I don't really think it can in real use, but it would be an internal error anyway. Okay. We would see it in the tree. So if we did it right, our tests are green. Hey, all right. Sorry you had to leave Code Wrangler. We just had the payoff of this thing. So a lot of time into this change, but here we are. Okay, so now we have the let's see. Well, expressions with operators are converted into a proper tree. Let's just say that for now. Okay. And I think let's just take a tour of these files, see how they're looking. Okay, here's our operator EQ. Notice there's no evaluation yet. So we can type 3 plus 4, but we won't get anything out or nothing good. Okay, our tests are okay-ish. That's a reasonable test. Yeah, that's all reasonable. Post order, I think we did okay with this. If it's an operator, pop to create the new tree and append. See, expressions, I just don't think that can happen. Who does the throw? It's not post order, it's the parse. The builder. Yeah, it's this thing can throw. It throws a precedence error. And that's probably okay. We maybe could get rid of that. If the list of expressions, if we just returned an error in the list of expressions, I think that would be okay. We want to get out because we compare two operators, we don't know the precedence between them. Like, I don't want to get in any kind of infinite loop where it looks less one way and greater the other or something like that. I just want to return out. Let's change that. Precedence parser tests. Okay. I just made some formatting changes so far, so let's check those in. Okay. Kind of a minimal message, but okay. Yeah, let's get to the top. We had an error. Yeah, let's change this. If you only have an end of file, what should you do? I don't know. Empty one coming back, and then the precedence thing doesn't push anything. No, this is the one I want to worry about, I guess. All right, so if I do parser dot parse of, well, I guess I got it there already. It's this I can get rid of. Parser dot parse. Well, let's take assert equal. Parser to parse, comma, and a file. I think that should be equal to an expression, no, what do we call it? Error expression, error messages dot, and the error is precedence parser error. Close that one, close that one. Oops. Parse that, that, and that. Okay. Oh, that's the extraneous one. Okay. Complaining about the try, right? No, the message. Okay. Let's get that. Comma may not be the best choice. Now what you complain about the try? No. Okay. Let's take the try off. Or the throws off. And we'll just return empty array for the moment. Okay. I should get complaints about the tries. Completely no calls to function occur. Generic parameter expression versus error expression. Parser.parse. Oh, it wants an array of stuff. Let's see these. All right. We don't get the error expression yet. We're going to return that. Error expression of error messages dot precedence parser error. Right. Everything. Yeah, everything either comes through this return or this return. I think this should pass, and I think we should be able to simplify parser. Okay, so what we did was make precedence parser return an error expression rather than throw. Okay, and now our parser should get simpler. Post order. Yeah, I think this will just all fall out. It may need a little help. We'll see. What's the No calls, throwing functions occur. Oh. Again, he's not quite awake. All right, so there may be some error message that no longer can come out, but no, I guess we're okay. All right, so make main parser return error expression if precedence parser fails. Okay. Now I think we should be able to run our app. Let's see over here, and I think we can say 3 plus 4 and we'll get a failure. Internal error should not happen. Okay, and that error comes from, let's find operator. All right, operator does not override evaluate, and expression provides a default. Okay, so, well, this is certainly no change. Okay, that's a harmless change. Oops, override. And actually, we have a better... This is really not yet implemented yet. I think we have that, yeah. Some test may check for this. Let's see. Oh. Okay. Interesting. So we have the REPL is read, evaluate, print, and print works, but evaluate doesn't. Evaluate is the read works, okay, because it produces this operator tree, and then right here we say, oh, we don't handle it. Okay. Let's see. So make default evaluate expression dot evaluate return not yet implemented. I think that's a better message. Yeah, far better, right? Okay. Let's see what we can do. So, well, there's sort of a simple way and then a hard-coded way and a more flexible way. And maybe we'll just start with the hard-coded way, and that'll be what we get today. So the hard-coded way is we have operator. It knows the token, and we would like to evaluate it. Okay. Evaluates to error string. Well, variable x. I think we can get the same thing if we did integer value 3 and integer value 4. And they have the advantage that we can evaluate them. Okay. Evaluates expression. Yeah, that's probably enough. Okay, evaluates expression. Well, we would like this to really be integer value 7. So 3 plus 4 is 7. That should fail, of course. Gonna close some of these things. Whoops. Probably could have kept that last one. All right, so the evaluate, well, let's pull the left-hand side and the right-hand side. The left-hand side is, well, we want to evaluate it in the context. Whoops, that's... We'll evaluate the left, evaluate the right. Okay, that's the 2 fields we have, well, 2 of the 3. And then the operator, if op equals plus, return well, what do we have to do this? We have all this query 2 stuff. I mean, this is convert to plus plus xy. Let's take a peek at convert to, refresh ourselves. All right, so this is kind of a very functional thing, but this is the thing that says if they're both integers, return an integer. If either one is a float, return a float. Yeah, figure out which argument is a float, convert to float, and then return a float. So I think that's an okay function to call. Convert to plus, evaluate with x and y. Well, that's left side and right side. Okay, so the convert to is converting the plus function and the integer plus and double plus into a joint function that checks types and returns the right stuff. And if nothing else works, well, this must be the case. Okay. Well, we had our operator tests. I think they should be passing. All right, and now let's try 3 plus 4. Evaluate 7 number, yay. And let's do 3 plus 4 times 5. Evaluate internal error. And that is, we don't have a times. We don't handle times. Okay. Right. So, I mean, we can go through adding every operator, and that's not impossible, but it would be nice to just have a map, right? So, let's just get a type off of this. It returns expression, expression goes to expression. Okay. So, and I don't know, you're going to call this a refactoring or not, but let's let op functions be a map from a token to expression returns expression. Okay. So we'll need to assign it. And this is the thing we'll want. Let's add op functions, define op functions equals well, token plus goes to this. Okay, there should be no harm in this because I haven't hooked it up. But I hope it builds. Okay, now I should be able to use it. Equals op functions of op dot left side, right side. Or well, if we don't have anything, I think this is where super.evaluate goes. Still not quite right. Must be expression goes to expression goes to expression optional. Coalesce using the optional value. If the function, okay, let's contains where, oh, these things kill me. I just want to ask if it, let's try it this way. Op functions of op is nil. Then let's return super.evaluate of context. Otherwise, op functions of op, we just call it, and I think it just evaluates. All right, now this case, we don't care that it's plus. All right. If there is no defined operator function, we'll just return it, but this can't happen anymore. All right, so we evaluate the left side, evaluate the right side. If we know how to use this operator, well, if we don't know how to use this operator, it's an error. And, you know, we're defaulting up to somebody who reports an error. And if we do know how to evaluate it, we do it. All right, so this should work. Now, oh, let's push this. Okay, make evaluate work for plus. We can do the same stuff. Well, that wasn't very good. Minus times Now this one, int divide, float divide, that's hard. Let's save that for another time. We don't know about exponents. I don't know if they're defined on ints or not. But these are the three we definitely have. I don't know what the Elm percent operator does. Is it exactly the behavior of the Swift one? All right, but let's run this. So for simple primitives, we expect this to just work. So I should be able to say 3 minus 2 plus 4, which is 1, 5, should be 5. Oh no. 3, let's try 3 plus 4 times 5. Okay, 23, that's correct. 3 minus 2 is unknown precedence. So precedence, we need to look at, I guess, our parser. Did we define the minus operator? Where did we initialize that? Parser precedence table. Oh, no, we did not. Okay, it's time to find the real deal. We need to get the precedence and all that stuff from Elm and make it work. Okay, I think we'll take one more 2-minute break here, and we'll come back, do the research on the Elm side, and get this thing pushed pretty far. Maybe not quite all the way, because I don't necessarily know how to deal with every operator, but we'll get pretty good. 2 minutes. Welcome back. All right, so let's find hopefully somebody will just tell us a table of Elm operator precedence. Yeah. SR number. No. Let's try in here. All right. Seems like we were here. Maybe with TextMate we can find it again quickly. Recent. Whelms. Yeah, so we had like Infix L or something. Well, we can see lots of, this is the initialization of the various functions. Div rem mod. I think this is JavaScript, so I'm not sure it's going to be helpful. Utils. I don't know what I'm bumping. ToString. Will it open in the same neighborhood? Yes. Basics. Grep minus R infix L. Oh. Basics.elm. Oh, that's a JS. Ah. Basics.elm. That's going to be better. Okay. There's those. Well, we can take this stuff right away. Put that in our to-do. Infix R. I never would have occurred to me. That seems funny. When used infix, left or right, the operator short circuits. Left is true, we don't evaluate right. But if the precedence is right precedence, A or B or C is the same as A or B or C. I guess that's okay. Yeah, wow. Never occurred to me. And I'm not sure if we handle non-associativity, but we'll find out. Search route 6+. Oh. Cell 6+. Okay. So we want to get these in our parser. I'll just copy a chunk at a time. Thank you, but okay. Okay, plus is 6 left associative. Minus is 6 left associative. Star is 7 left associative. Slash is float divide is left associative. And up arrow is priority 8 and right associative. All right, next block. We have int divide. Excuse me. and percent. Oh, should get one of them right first. Do we? I think maybe we added none. No. Where is that? Precedence table builder. We don't have a none case. We'll add them and then comment them out. Okay, this is equals, double equals. Precedence for none. Not equal. Precedence for none. Less than. Greater than. Less than or equal. Greater than or equal. And I'm going to add a to-do. So in Elm, you can't say A less than B less than C, because it's non-associative. That means you should only have one at a time, like that. All right. That's those. We'll put 2 right associative, and this is bar. 3 is ampersand. 3 right. Kind of breaking them up by value. 5 is right parenthesis plus. Well, let's add the zeros while we're down here. The less than bar is right precedence 0. The bar greater is left precedence. and then the 9s. Is right and greater is left. That always seems a little weird to me to mix the same level. Okay. Nuns are going to require some research. Because we didn't get a definition for that case in our parser, so we'll have to see. It really is an error case now. Okay. Yeah, maybe it may just fall out. All right, so I think we've addressed all these. I'll put this down with our done stuff, I guess. Add all precedence relations. And zeros. Oh, that 5's out of whack too. Zero, 2, 3, 4, 5, 6, 7. 8, 9. Okay. Merge new parser with the original parser. We did that. Semantics of operators. Okay, so where are we here? We got our parser. Every test should still pass. Okay. Except non-associative. Okay. And let's see what Elm% operator does. Modulo A% B. Okay, that should be okay. I think this should be okay. We just have to name it that way. Divide. Well, no, it's not really correct, is it? Let's do percent because that's an easy one. Convert think you can do modulus. I don't know. Does double do modulus? For floating point, use truncating remainder. Okay, we can't do that one easily either. Okay. We'll have to build up a set of converts that handle specific cases like that. Or, yeah, we'll have to define our own operators, basically. What else do we have? Plus, minus, star. Those two are special. That one's special. These relationals we don't really do. Comparable types. We haven't addressed comparables. Logicals, they only work on booleans. Okay, well, it's pretty restricted, right? Plus, minus, star, but I think that should be okay. And we can rerun. Let's make sure this works for the expressions we want. Three minus 4 plus 2 plus 4, 5. Okay, should be 4 plus 2 times 10 should be 24. All right. Cool. Another one is parentheses. I'm not quite sure if this is going to be right. 7 times 5 should be 35. Yeah. We gotta figure out parentheses. And I think I know what's going on there. We did plus, minus, times, and we need to do remaining operators other than plus, minus, times. This one we did. I think I know what's going on with the parenthesized expressions. I think they recursively call, but they call expressions probably, and not the real one. Not the operator expression, because we just added that one. So expressions, where's the parenthesis? Left paren, return parenthesized expression, yeah. Right. Yeah, I think these should be operator expressions. Okay, so we'll just say check out this. We're running low on time. This is the recursion. Our recursion, we let you do parenthesized expressions, but they don't know how to handle operators. They only handle function calls like the old way. All right, and I think we're going to move this up and deal with that first. Non-associative operators, I'm going to have to do a little research and see how the precedence parsers handle that. I think somehow they put an error in comparing it to itself. So let's see. We have the rules here. So normally any operator, where's operator versus itself? Yeah. If it's left associative, we have rules. If it's a right associative, we have rules. But if it's not associative, we don't have a rule. And I think, yeah, I'll have to see. I think maybe we just leave out these rules. But I will investigate. All right. So we'll pick up next time We got a little ways to go on this, but we've made good progress. We've got this new parser integrated in, and at least some things working. Uh, we defined some more functions. We got a bunch of other operators, and we will handle this stuff next time. Next time is tomorrow, Thursday, 1 to 3 p.m. Eastern Daylight Time. And thanks for joining me today, and I hope you can join me in the future too. Bye-bye.